Welcome back. I hope you have enjoyed your lunch. Our next speaker is Felix Frank, and he is talking about differences between Puppet and Ansible. It's your stage.
So yeah, welcome. Thanks for being here, everyone. And yeah, as was announced, we are talking about Ansible, talking about Puppet. Yeah, it's great to be back at the OSDC. I guess some of you might remember me from last year, but I saw some new faces, and yeah, I guess it's just common courtesy to introduce myself a little. So I'm Felix. I'm here from Berlin. I'm a Linux operations person at the Unbelieving Machine company. We do managed hosting and lots of big data things. And yeah, I've been doing Linux things for way too long at this point, probably. And I like tinkering with open source things, especially configuration management things. Full disclosure, I'm kind of an old Puppet fanboy, but I'm working hard at also getting my accredited Ansible nerd badge. So I don't think there's much of a conflict of interest here. And yeah, I'm pretty serious about going about the city per bike. That's just the thing I do. And I'd like to open this up by reading a short text to you. Here it is. The pig go. Go is to the fountain. The pig put foot. Grunt. Foot in what? Catch up. The dove fly. Fly is in sky. The dove drop something. The something on the pig. The pig disgusting. The pig rattle. Rattle with dove. The dove angry. The pig leave. The dove produce. Produce is chicken wing. With wing bark. No quack. So, does anyone have any idea who might be the author behind this rousing piece of literature? Computer. Computer is actually a very good guess. So, of course, there's a bit of a story behind this. So, it goes as follows. Apparently, there was this group of people at some point, and they had a lot of money, and they also had a problem. They had this IT system that received data from some third-party system, and that third-party system was a bit of a black box, and the data that it sent and that the group in question needed would arrive in all manner of formats. Like you had data imports once a day, twice a day, and one day there would be comma-separated values, another day some binary format or weird text things, what have you. It was a mess. And that meant that the IT staff on the business side had to put in lots of manual labor, and it wasn't great. It was always slow. People had to scratch their heads a lot, and yeah, they were looking for a solution. So the bosses had an idea, and the idea was, hey, so we hear there's this thing called artificial intelligence, and it's supposed to be pretty great. And wouldn't it be cool if we had an intelligence system that could figure out how to get the data that we need from these weird formats that we are receiving? So they went and found an AI expert. And now this is a story from the days when machine learning and artificial intelligence weren't as much of a buzzword as they are these days, right? So now everybody wants to jump on that train. But back in the day, the only people that really knew how to do this kind of thing were folks that were at a very large university that would actually have the means to have this kind of AI institute. Really wasn't so much of a big deal at the time. So They did manage to find someone who had the right mix of expertise and was capable of designing the kind of neural network that that the folks were after, and they brought their problem to that person, and their reaction was, of course, wait, what? You want to train a neural net with these binary data formats, and then you expect it to like reliably form data that comes in possibly any of those, and turn this into the format that you require. That's not a good idea. That's really not what you want to do with AI. What you want is build a couple scripts that recognizes the formats that you know about, and be done with it. But yeah, I guess the customer was adamant. They really wanted to have artificial intelligence, and they were really stuck on that idea. So expert says, well, I guess it's your money to burn. Let's see what we can do. So money was spent, systems were bought, time passed, and the expert toiled away, and eventually the AI was there, and it was trained, and it started its job, and really surprising no one, or almost no one, it didn't work at all. It hardly got any useful data out of the stream that it would get from the remote system. So, well, expert says, guess I told you so, and just geez, give me some old Linux box, and I will build some scripts that do what you need, and then let's just part ways, and everyone will be friends. And that happened, and everyone was more or less happy. But the thing is, the AI cluster had cost a lot of money, lots of hardware had been bought, lots of time had gone into implementing the neural network, so it was decided that it wasn't really worth just scrapping it. So the cluster apparently is still operational, and but it didn't really have a job to do. So some tech got bored at some point and decided to let's just train it with some pros and have it come up with new stories on the spot. And rumor has it that this fine little text that I read you earlier was written by that very AI cluster. History only knows. So, of course, there's a moral to the story, which is you really shouldn't use the absolutely wrong tools for your given problems. You know, there's also that old IT truism of when all you have is a hammer, then sooner or later everything starts looking like a nail, and you're just going around and smacking all the things. But if you find yourself in this very position where everything starts looking like a nail to you, you may eventually find yourself with a system on your side that will tell you, no, quack. So speaking of tools, of course, I want to take the angle of looking at config management tools, as you may have surmised from the title. What do I mean when I say config management? I'm thinking of tools from this space, like, you know, CF Engine, Puppet, Chef, Ansible, Salt, MGMT. And as the title suggests, I'm gonna focus on these two, Puppet and Ansible. I assume that I'm telling nobody here anything new, but let's just go through the motions. Why do we like config management? Why is it great? Of course, there's the aspect that if, in the ideal case, you don't have to do any manual tinkering on your machines, your production is safe from typos and stuff, more or less. And also, you don't get to write these fancy installation guides anymore, like this is how you install Apache and this is how you make a web server for customer B, because yeah, that's all in code now, and which also makes for great repeatability. If you have built one web server for customer C, then installing 2 or 3 more servers for that customer becomes easy in the ideal case. And my personal favorite, when infrastructure becomes code, we can apply all the lessons that software engineering has painstakingly learned, and we can apply workflows that they have come up with. Like, we use versioning systems, we can do continuous integration on the infrastructure level. There can be code reviews, all these nice things that just didn't used to be a thing for operations, but now they are, and that's just great. Okay, let's have a quick show of hands. Who has never used either Puppet or Ansible? And who has used both of them? Oh, that's a lot of people. Cool. And I assume that the rest has either used either or the other. So to get everyone on the same page, I'm just going really quickly through the basics of what they look like, so that everyone has a bit of a feeling, even for the stuff that they are not immediately familiar about. So how would it look like if I use Puppet to model a web server that should do things using, say, Varnish as a cache, Apache for content delivery, and let's say a JVM to run the actual web application? In Puppet, you might write 3 classes. You probably wouldn't, but you could. And each class in Puppet will model one of these services, and is in turn implemented using a number of resources. And each resource is like, could be a file, a package, or all these basic building blocks of a running system. And they're organized in this way, and Puppet can treat each of them individually and work with them. Puppet essentially can put them in any order that it pleases. So you will define necessary orders, like you have dependencies between resources, because like you probably can only write a config file after the package has been installed, because otherwise there might not be a directory where you can put the file, this kind of thing. And Puppet then will go ahead and find an order that satisfies all these dependencies, and in case of failure can tell that, okay, dependencies have failed, I don't have to look at a certain resource because it couldn't probably work, this kind of thing. I'm really glossing over this. You could probably do a whole session, like Puppet introduction. This is not this session, of course. We have a lot of more things to cover. But Ansible looks really similar, but has some differences in the details. You would probably write 3 roles in Ansible to model your 3 aspects, and each of the roles consists of a number of tasks, which are pretty similar to the resources that Puppet uses, but it's kind of like a script. The tasks are run from top to bottom. There is the concept of requirements and dependencies in Ansible, but it's different. It's not very flexible, and yeah, using it has its own challenges. Architecture-wise, Puppet often, not always, but I say usually, has a central server called the master, and this is where the code, the infrastructure code, lives in Puppet's manifests. The master itself is basically just a REST API. There's a key value store called Hira that holds the actual configuration data. In there you put stuff like, okay, which port should Apache use on a given system, or how much memory would I supply to the JVM, or this kind of things. And there's a specialized database called PuppetDB, which stores all kinds of information, like information about the systems that Puppet manages, and also the instructions that the Puppet master sends to the managed systems. It does this by speaking to the so-called agents. Each machine that Puppet manages runs Puppet agent, and the agent just queries the API of the master to receive instructions. There's another part of the stack is called factor, which is another piece of software that runs right alongside the agent and gathers all kinds of information about all the systems, like how much RAM does a system have, what operating system is running, whatever. And this is communicated to the master. So, Puppet architecture in a nutshell. With Ansible, that's actually, this is one of the bigger differences. You have an Ansible initiator, and that's not a special machine. It can basically be any machine. It can be this laptop. In fact, it often is this very laptop, or it could be yours. But it could also be any machine in the data center. And all you need is the Ansible software on this machine, like on my laptop, and the inventory, the infrastructure source code, and Ansible will go ahead and connect to all machines that I want to manage through SSH and do its work. That's really nice. And all the things that it needs are part of the source code, which is basically in two parts. There's the inventory, that is basically on the one hand the list of machines that I'm going to manage, and also a store of variables, kind of like Hira, that defines just the details about each machine. All right. Let's speak a little about language, because this is whenever I think and speak about Puppet and Ansible, that's a thing that can get me a little riled, because there are some language clashes. So I already talked about resources in Puppet and how each of them is like a file or a package or a service, what have you, an Apache vhost. And this is called the resource types, and there's a lot of them. And Ansible has that same concept, of course, but calls these modules. So an Ansible module is the same thing as a Puppet resource type, basically. Unfortunately, Puppet uses the term module as well, but means something completely different. It's basically, a Puppet module is a piece of code, like a library or a standalone collection of classes and things. And Ansible has the same concept, of course, but calls it a role. Now, in turn, role, unfortunately, in the Puppet world is used in best practices. And a role to Puppet is this concept of you have a certain number of roles, so that each machine in your data center can have one specific role. And yeah, as such, works on a very different granularity than Ansible roles. So must be careful to avoid this terminology when speaking about the concepts of your management and implementations, because yeah, the term role to Ansible means something very different. Ansible doesn't really have anything like the Puppet role. There are host groups, and they can do a similar job, but it's yet again a different level of granularity. So yeah, doesn't really work. Finally, as I noted earlier, what Puppet calls a resource in Ansible is a task. I think that one is actually pretty apt, because they are different. And it's just good to keep that in mind, that when you speak to someone who's familiar with a different tool stack, that they might use these other terms, but they're essentially the same concept. All right. Okay, let's try and get a feeling for what it's like to use either of these tools in your everyday life. With Puppet, what you will be doing in your day-to-day is, of course, you're editing your source code, your manifests, and also put data into your Hira stores. This is what Puppet code looks like. It's a bit like C-ish, PHP-like. There's curly braces for blocks. There's if expressions, and This here is a resource definition. In this case, the resource type is package underscore use. That's the type of the resource, and the resource has a name. And the whole thing is written kind of like a hash structure in, like, you know, Perl or Ruby. So that's Puppet language in a nutshell. Higher variables typically stored in YAML. It's just the same choice to represent data, so pretty popular. But there's different backends as well. You could have a database or different things. There is open source code available for Puppet. You can download modules from the internet, and Puppet has this portal called the Puppet Forge, which is kind of like the Ruby Forge or PyCentral or what have you. Like most programming languages have this kind of repository, and for Puppet it's the Forge. And there's a lot up there. So most of the most popular kinds of software that you have in your data center, you will probably find support for them on the Puppet Forge. This is a visualization of one of the most basic best practices pattern. I won't go into that really, out of scope, but by having your Puppet classes organized in rows and profiles, this allows you to, you have this design pattern that brings some order in your code base and enables you to essentially remain sane while your infrastructure keeps growing, and you have to have a code base that is still maintainable and readable. So rows and profiles are really helpful for that. You can use so-called external node classifiers, and one of the most popular is the foreman, which is a cool tool. And you get a web interface. You can deploy your machines. Gives you lots of power. There's a orchestration tool called collective. I would have included some kind of diagram that shows you how it works, but it turns out it's kind of complex and it's beyond scope. So I just included this magical unicorn here. But yeah, collective for the orchestration needs with Puppet. There are visualization tools like Puppet Board that will just give you a view into what's going on in your infrastructure and show you all the precious data in a manageable format. And yeah, it's a really rich ecosystem of tools that help you take control of your data center. And that was a lot to take in. So just let's take a deep breath. All of this is not really important to what I'm going to relay here. I'm just trying to level the field a little, give everyone a bit of a feeling what it's like to work with the tools. So let's cover Ansible real quick and then get to the actual meat of the presentation. So with Ansible, things are similar. Of course, you are writing source code and putting data into variables. You will want to put most of the code that does work in these Ansible roles, so that there's some your code is organized, and the playbooks that you keep hearing about are basically the way to tell Ansible, okay, so for there's this workflow that I have, and on these hosts I want you to apply this collection of roles and make those work. It kind of looks like this. This is code for a speculative role. Fair warning, if you really don't like YAML, you will not like Ansible, because it's just YAML all the way down. Everything you write will be in YAML. But if you manage that, it's kind of intuitive. There's templating going on in all the things that you write. So this is a template expression, and that's if you've seen the Vault presentation, it's basically the same deal. the things in the curly braces just gets substituted. The playbook itself may look like this, and tell the engine, okay, do things to the web server, and then do things to proxy servers, what have you. Ansible also has an open source repository called Ansible Galaxy. Basically, same deal as Puppet Forge. And defining the variables that have your configuration data, again, pretty much same deal as in Hira. You write YAML files and you have keys and values. That's what's going on. I've shown this diagram before, but I want to reiterate it because it's really such a huge deal in Ansible. You have your code in your Git, and wherever you get your Git repository, you can just run Ansible, and it's just a very easy and yeah, flexible way of using your software. You're not tied down to this central server that has to be maintained, it has to be super secure, etc. That's just, yeah, very central part. The foreman also has Ansible support, so you can use similar aspects, kind of like with Puppet. There will be a presentation about the foreman later the afternoon, so if you have not really got a feeling for that, but might want a web interface for your Puppet or Ansible stuff, you might want to check the foreman out. It's supposed to be pretty cool. I have not really tried this. Another thing I have not tried is Ansible Tower, but the thing is, without Ansible Tower, some functionality in Ansible that I consider rather crucial is just missing, and people that have asked for certain things on mailing lists, etc., have just been like redirected to, oh yeah, that's available, but it's in Tower. And it used to be commercial. Apparently, it's going to be freely available eventually, but it's not yet, and I haven't tried it. It's supposed to be cool, but if you don't have it, Ansible can feel like a pretty bare bones experience. So let's talk about how these tools are generally pretty similar. So I guess it's time to cut to the chase and talk about how they are really different in some ways. So what I'd like you to understand about Puppet is that the idea of Puppet, when you go ahead and implement management of your data center using Puppet, is that you create this abstract model of how everything works. And Puppet is the engine that will make this model come into reality by by maintaining state, a certain state on each and every one of your machines, and this state should eventually converge into a pretty much into an unchanging global state. So there can be instances where Puppet has to repeatedly make some changes to get you where you need to be, but ideally this will be finished at some point, and then Puppet will not have any more work to do, except of course you change the code in order to introduce change that you need in your systems. Let's try and visualize this a little. So imagine this is part of your whole infrastructure, like a couple of rack-mounted servers, and you have your Puppet set up, and this little colorful box is supposed to represent the global state that you need your infrastructure to have, and it's basically the state as seen by Puppet emerges from the code that you write, and that basically you supply some manifest code for each node that is in your infrastructure, and the code of course uses data from Hira, it uses data from the Puppet DB, like the facts that have been collected by the different machines. So it's this blob of information that Puppet compiles into these catalogs, which are for each and every machine. The catalog defines what Puppet would like it to look like, basically. So these can be of different complexities. So for one machine, Puppet might just manage very little state and only care about a handful of files. On some different machines, it might really have control about hundreds of packages and dozens of files, and there's a whole range there. But the thing is, Puppet has this view for each machine, this vision, if you will, and it constantly projects this view on each machine. And if a machine is not synchronized with this representation, with this catalog, then Puppet will take action to make it conform to that. The flow of this is basically each machine will from time to time call in to the master and make a request for a new catalog, and at that time it also sends its current collection of facts that happens on each request. And this may mean that since Puppet now received new facts and compiled a new catalog, that its internal representation of the system state may change, because each catalog can use various information from PuppetDB or from Hyra. And as the new catalog is being sent out, the internal model has changed, and this will then perhaps manifest itself in a change to the catalog that different machines will eventually receive. And this could just keep happening because changes lead to other changes. But again, the goal of your code should be that your systems can converge into the state that Puppet can then maintain more or less indefinitely. Okay, who's confused? To take the cue from James. That's good. Nobody yet. With Ansible, it's a very different deal, actually. So what Ansible does is it gives you the tools to implement things that happen in a distributed system. So Ansible doesn't care about state and that it converges in some unchanging state. You can, of course, write code that, if you just keep running it, will eventually have your systems in a state where no change will need to occur. But that's actually not Ansible's strong suit. The thing is, you also have this representation of what your infrastructure is, but the code, with the code, you are very free to say, I really just want to project this very certain part of the information to very specific machines, and you are very free to do this. Again, some visualization. The Ansible inventory is like that representation in Puppet. It's a lot more static because there isn't that kind of floaty state that Ansible uses to do its work, because there isn't this kind of database that's being maintained. It's always just the inventory as you check it out from your Git or Subversion or what have you. And okay, let's just go through the motions of what happens when you run a simple playbook that, say, speaks to these three machines over there. First thing Ansible always does is run the so-called setup module, which means it receives information kind of like, it actually does support factor. So if you have factor on your machines, as you have with Puppet, then the information from factor is available as so-called host variables. And Ansible also, even without factor, Ansible will get some information from all the machines and populate these host variables. So it is kind of like the whole puppet dance with factor and things, but the thing is these are very fleeting. So only once you launch Ansible, these host vars come into existence, and as soon as Ansible is done with the job at hand, these are just gone. So with this now complete set of information, Ansible goes ahead and tells the machines what to do in order, and that is basically it. All the things that are in your code will be run on all the machines in parallel, and that is it then. A more complex playbook might talk to all parts of your infrastructure in turn, collect all their host variables, and finally, when it has this larger view of your whole infrastructure, it can speak to this one very special machine and register things there. I don't know, like put all the IP addresses that it collected into a hosts file, or configure some LDAP ACLs, what have you. These kind of things. So summarizing, you have, on the one hand, you have Puppet that really has this given idea of, for each single machine, how it should look like, and always tell each machine to get in line and be in that state that it imagines. Whereas with Ansible, Ansible is basically it does what you want whenever you want it, but it's a very point in time thing. I realize this is probably very abstract and has maybe not yet told you so much about what the real difference is. So a metaphor that I've come up with to even make it more clear to myself what I should try and make the tools do is to imagine that your data center is a theater stage and all your machines are actors on the stage, and you want them to make a certain performance, right? So what Puppet does to make things happen is you have this person behind the stage, and what they do is they are constantly writing personalized scripts. So each actor gets a personalized script that tells the actor what should it do and in which order, and it hands the scripts to the actors and then pretty much doesn't care. It relies on the actor to do the correct things with the script that it created. Whereas Ansible doesn't bother. Ansible really just is standing behind the stage, and it's telling the actors, okay, now you folks go on stage and I'll be telling you what you do, and everyone do what I tell you, and usually all the actors will do the exact same thing whenever they are on stage, and Ansible gives the same instruction to all of them. So really very, very different ways of setting up a play, and it really depends on what kind of performance you expect. So I guess neither of them will be able to do an elaborate Shakespeare, but each of them can do magnificent, pretty great things that happen. So it just depends. What I'm getting at is it's problematic if you go ahead and try and make the things that Puppet does happen with Ansible, because they are really quite different in their approach. Also, in case you have heard James talk about MGMT, I guess in this metaphor, it's like there is no director, and all the actors just have, I don't know, GoPro cameras on their heads and Google Glass, and just, you know, have this elaborate choreography going on, and everyone is always on the same page. Which is, yeah, interesting. Don't know about Shakespeare, but can do awesome things, definitely. So a thing that keeps coming up is that I think there's even in some best practices document or other that people create a site.yaml file for their Ansible, which is basically the playbook for all the things, how to manage the whole project, whatever. And yeah, I'm really not down with this approach because there's issues with it. Not the least of which that it just doesn't scale. If your infrastructure grows, you will have yeah, exponential growing pains with Ansible. And yeah, some other things that you might be wary of if you approach Ansible with a Puppet mindset is there are tags in Ansible, but they are different from Puppet, and I found them to be less flexible, and you cannot really rely on them to organize workflows over longer time. They're good one-shot tools, but probably not flexible enough to satisfy all your needs on a longer time frame. I found it much better to have specialized playbooks. Like when you realize you have these specialized tasks that you need doing now and again, just create a playbook that does just that. And also with Ansible, you really want to once in a while create a playbook that is just fire and forget. I need to run this now. I just write the playbook. I won't even put it to Git. It's just for making things happen right now. Talking about dry code, like you don't want to repeat yourself, copy-pasting code is usually bad for maintainability. And if you try to do this on the level of your playbooks, like on all the orchestration code that you have, you will have a hard time. Like if you want to make sure that there is this one playbook file, and this is the one that invokes Apache and Varnish roles, then that should be the playbook that does that. And when I need this in other contexts, then I will include this playbook in another playbook or something. And if you do this consequently, then you will end up very frustrated. So my advice is not to bother even, but just do whatever it takes and be liberal in your playbook design. Now the roles themselves, like the Varnish role or Apache role, there should be separation of concern. So a thing that is managed by the Ansible role, by the Apache role, for example, should not be managed in other roles as well. That is the thing where you want to be dry. Last but not least, there's lots of best practices that is advertised, and one of the first things that I've been told about Ansible by someone who had more experience and kind of introduced me was, yeah, look at those, but not all of them are really great. There's some tips on how to structure your code, etc. And some of it is really good, others not so much. So it's good to have an open mind, be looking around, and yeah, not to take everything to the letter, perhaps. Let's take a closer look at what it looks like when folks go ahead and try to make Ansible into this Puppet shape and do everything through site.yaml. So you have your Ansible infrastructure, and first thing you do is, of course, Ansible connects to all machines, gathers their host variables and information, and then it will talk to one of your server groups and let all the roles run that make up a server in this group, and then it will connect to the next group and apply all rules that are for that group. Then the same for this third server group and the fifth. And at that point, you probably want to die because it's slow and it's boring, and why even bother? This kind of thing, yeah, Puppet just does it better. What you want is Ansible gives you these amazing tools to orchestrate your things and to be flexible. So I don't know. Probably first thing you do is go to all machines and configure SSH, but then you deploy your database not only packages, but also perhaps some base data if it's not there yet. Your web servers get deployed with the stack, and then you can go ahead and deploy the application, which, by the way, is probably in a playbook that is included in this workflow, and later you will just run the application deployment steps. And then you run some initialization that uses the software that you just deployed, and has the web servers already communicate with your database. Which in turn is probably a step that you won't be reusing time and again. So in the future, you'll probably just deploy your software. And Ansible makes it easy to separate all these things out because you don't need code that is unchanging for a given machine. Sorry. Ansible can also just go ahead and wait for the application servers to reach a certain stage of initialization. And once it has realized, okay, application is ready, then it will enable traffic from the outside on the proxies. All these kind of things, and it's really fun to watch Ansible do this, and you will impress your coworkers, and yeah, I guess that's a much better way to make use of the tooling. So, yeah, Ansible is great, actually, and I guess there are some signs if you are asking yourself, should I be deploying Ansible? Should I opt for Puppet instead? So one sign for that to me points toward Ansible is always you need to cover software deployment, code deployments in your configuration management. And Ansible makes this pretty easy, and Puppet is notoriously bad at that. So, hands down points for Ansible. If you have lots of network infrastructure, like routers, switches, what have you, and not so many Linux machines, you may have a better time with Ansible, I guess. Puppet can do these things, but it can be a little more natural with Ansible, I guess. If these kinds of one-shot management tasks are very commonplace, and you just don't see yourself modeling this state that the infrastructure is in over a longer period of time, that of course lends itself to Ansible much more. And last but not least, if you are deploying Python everywhere after all, but Ruby is not a thing you ever use and want to touch, then might just be an argument for Ansible rather than Puppet, if it really comes down to this. Of course, on the other hand, there are some indications for Puppet might be preferable over Ansible. So if you're mainly concerned with the operating system platform and there's perhaps a different team that will do all the application deployments and stuff, then yeah, Puppet will make your life easier, most likely. Is your environment very heterogeneous? Like it's not like you have one operating system on all your machines, but actually there's like 3 different versions of RHEL and 2 Ubuntus and also some Debian boxen. Puppet handles this quite gracefully. Ansible, less so. The thing about Ansible is that it has a really low learning curve, and I think that it's why it's become so popular so fast. People just can get started with it really quickly, but the more complex things you need to implement, your life gets harder. And Puppet is just very mature, very powerful, and if you value that, then you might lean towards Puppet. And of course, the antithesis to what I said earlier about Ruby and Python, if Ruby is already a thing in your tool chain and Python is absolutely not, then might be sensible to lean towards Ruby. Also, if you are very careful about not having Python 2 anywhere, you might not want to use Ansible. Of course, there's that question. Should I perhaps, I mean, both Puppet and Ansible have strengths, have weaknesses, so should I combine them to complement them? And yeah, sure, you can do that. But keep in mind that this implies that you need knowledge in both areas in your team. And it will make life a little harder because you will be constantly asking yourself, okay, should this be handled by Puppet or should this rather be in the Ansible scope? So I think it can make sense to limit yourself to one tool rather than the other because they are both quite powerful. So you might just get away with choosing one. Okay, and one of the most important questions to me personally is, of course, there's always discussions, right? They are great tools, and people love them, and you will inevitably run into someone who loves a tool that is different from yours, and yeah, I think it's important that we have a good way to talk about these differences, and yeah, I think it's the most important thing to keep in mind is we should be empathetical, we should be friendly. In fact, if anyone's a little distraught by the things that I relate here, I'm giving out hugs. Find me on in the break room, and yeah, I hope we can all be just cool about these kind of issues in the future. So that's it from me. Because before I go to Q&A, I'd also, as some folks before me, like to point out that Unbelieving Machine is hiring in Berlin. We might be even hiring in Frankfurt, and I guess in Vienna. And yeah, we do lots of amazing things in the operating space, but not only that, we're also hiring like management folks, engineers. Just have a look at our careers page. It's a cool company. Highly recommended. Now, thanks for listening. I'm answering questions, yeah.
Oh, wait 1 moment, please. Take the mic.
I guess I'll start because I'm not shy, break the ice. So you talked about having multiple different playbooks for doing certain different tasks. In your experience doing this, do you worry or suffer from the possibility of flip-flopping, like in that the playbooks define conflicting things, so each time you run, it flips that thing back and forth and back and forth?
Okay, so the question was about when there are different playbooks that basically target the same infrastructure, because I said that you probably want to have distinct playbooks for different kinds of tasks, and if this can cause problems of these are basically fighting and some of the resources that are managed keep flip-flopping between states as envisioned by the different playbooks. So I guess there is no sensible way that you can completely guard yourself against that. I do feel that I mean Ansible basically Ansible has a coherent view of what your infrastructure should be, and that should be all in your inventory. You want to make your inventory really represent what's going on, and each playbook will take a certain part of that and cut it out and send it to the machines that you're managing, but there should not be inherent conflicts there. Of course, the code can make it so that even from the same inventory, this one code path thinks Apache should be installed, and this other one thinks, oh no, Apache cannot be installed here, and you have this flip-flop situation. But so the question was from my experience, and my experience was not like that at all up to now. But granted, my code bases have not been super extensive. Is it a risk for infrastructure safety? Well, I think no. So you are structuring your code in a certain way, and there's always a risk that automation will just you make a bug in your infrastructure code, and the automation goes ahead and destroys your infrastructure. This is just a thing that can happen with management. I don't think that Ansible's or that the practices that you should apply to Ansible make this inherently more risky than any other tooling. I think there were more signs.
I think this goes in the same direction as with James. How do you ensure if you have to reinstall a machine that you get the same result if you use Ansible playbooks ad hoc and just run them once and forget them?
Right. So how do we ensure that we can bring a machine, say a newly installed machine, into the complete necessary state to do its job? Well, I guess that is a good argument for you probably want that site.yaml playbook around, so that you have this complete view. One nice thing about Ansible is that you can very simply say, okay, I'm running this, but I'm targeting only this one machine that I just provisioned. So workflows like that can be implemented, and sure, you must be careful that you don't miss anything like, well, duh, of course I have to run the application deployment playbook as well. That should not be a thing that happens. That should all be part of the site deployment flow. And there are some other challenges, but yeah, you should be careful about being able to do both, right? Good question, thanks.
Do you have any maybe strong opinions for masterless Puppet?
Do I have strong opinions about masterless Puppet?
Or maybe any opinions?
I think masterless Puppet is a great idea. Folks have been doing that. Like, you don't have the central master that does all the compiling and storing of things, but instead you ship the code to each machine that you manage, and each machine does the compiling and basically manages itself. This has implications on, well, you have to, where do I start? I mean, Puppet gives you some cool tooling to establish trust, which you will have to do yourself. But apart from that, if you manage to build all that, then this is a really powerful pattern, because it typically it can scale very well, and you gain flexibility. I feel that it takes a little more skill to set it up just right. So if you start with Puppet, I would usually just go with a master. And if you find that you're limited by this and you're getting more comfortable, then yeah, masterless is a really good alternative.
To extend the answer to James, I think it could be possible if you strongly divide your configuration or your playbooks for example, general tasks like SSH configuration, users, and such, into one playbook that runs on all machines, and then perhaps having playbooks that are dedicated to groups of servers, like, for example, these a playbook for your web servers, one playbook for your database servers like this, and taking care that you don't have conflicting or doubled roles inside of the playbooks, so the common and the others. I think there's a possibility of, or perhaps it's also in documentation, the grain of salt, not everything that is written in the official documentation is best practice, like having a definition of variables inside of your playbook code when you call a role. This is something that you definitely shouldn't do, and use all of your variables and configuration inside of your group vars and host vars, and keeping all the roles clean of customized variables and settings. This is just something I would recommend.
Yeah, agree.
And one thing that is quite different, at least for me, when developing new roles or modules is, yes, how to develop these new roles. I'm quite confident with using Vagrant and Ansible, and everything is totally fine because I can run perfectly on my machine, and I'm quite free from dependencies and don't have to set up a lot of stuff beforehand. And if I think about Puppet, there I have Hira and certificates and these and that. It's quite more complicated, I think. So this is just a huge argument for Ansible for me. Scaling, of course, is an issue, and when doing a rollout. And the last thing, perhaps later. I've totally forgotten.
I was going to stop you right there because we are almost at time. Does anyone have any question yet?
We have one more question, and we have time for one more question.
Great.
Actually, a question, it's more like an addendum. I found that Ansible is extremely good in making simple things simple and complicated things obvious. So that it's unlike Puppet, where you can have things that should happen together, but they're defined in a lot of different files. And the order is then also arbitrarily defined by requires and other things. Ansible just writes stuff that happens, bum, 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 in this order, and that is what happens. And that makes it pretty easy to read and understand what happens, so that in most cases where Puppet people would then require a test for a module and stuff like that, the Ansible person that does the same thing would say, why would I test it? It's perfectly obvious what it does, and that is actually what is there. So you just read the file, and then the need for all that goes away. That is also why all the Ansible stuff is much more ad hoc and simple, because it is designed for that, really. Also, never ever download any module, be it a Puppet or Ansible module, from the outside. Always download that, read that, throw it away, and then implement only the part that you need. Configuration management is about making choices, taking options away. It's the opposite of development, it's operations. Yeah? So developers create features because that customer might want things that way and that customer might want another way. But operators have the job of saying how we do things around here. And things that you don't do around here, they should not even have options and variables in code. So only write the code that you need when you write configuration management. That's the key, really, to not dying.
Yeah, I'm not really on board with the last point as well. So
I'm sorry, we have to finish. Thank you very much.
thanks.
And use all of your variables and configuration inside of your group vars and host vars, and keeping all the roles clean of customized variables and settings. This is just something I would recommend.
Yeah, agree.
And one thing that is quite different, at least for me, when developing new roles or modules is, yes, how to develop these new roles. I'm quite confident with using Vagrant and Ansible, and everything is totally fine because I can run perfectly on my machine, and I'm quite free from dependencies and don't have to set up a lot of stuff beforehand. And if I think about Puppet, there I have Hira and certificates and these and that. It's quite more complicated, I think. So this is just a huge argument for Ansible for me. Scaling, of course, is an issue, and when doing a rollout. And the last thing, perhaps later. I've totally forgotten.
I was going to stop you right there because we are almost at time. Does anyone have any question yet?
We have one more question, and we have time for one more question.
Great.
Actually, a question, it's more like an addendum. I found that Ansible is extremely good in making simple things simple and complicated things obvious. So that it's unlike Puppet, where you can have things that should happen together, but they're defined in a lot of different files. And the order is then also arbitrarily defined by requires and other things. Ansible just writes stuff that happens, bam, 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 in this order, and that is what happens. And that makes it pretty easy to read and understand what happens, so that in most cases where Puppet people would then require a test for a module and stuff like that, the Ansible person that does the same thing would say, why would I test it? It's perfectly obvious what it does, and that is actually what is there. So you just read the file, and then the need for all that goes away. That is also why all the Ansible stuff is much more ad hoc and simple, because it is designed for that, really. Also, never ever download any module, be it Puppet or Ansible module, from the outside. Always download that, read that, throw it away, and then implement only the part that you need. Configuration management is about making choices, taking options away. It's the opposite of development, it's operations. Yeah? So developers create features because that customer might want things that way and that customer might want another way. But operators have the job of saying how we do things around here. And things that you don't do around here, they should not even have options and variables in code. So only write the code that you need when you write configuration management. That's the key, really, to not dying.
Yeah, I'm not really on board with the last point as well. So
I'm sorry, we have to finish. Thank you very much.
thanks.
We will be back in 10 minutes with Dr. Udo Seidel talking about